Welcome everyone, I'm Adam. In this problem, for our given vectors u with components 3 and 4 and our vector v with components -1 and 5, we're going to be finding these 5 things. A, the dot product between u and v. B, the dot product between u and itself. C, the square of the magnitude of the vector v. D, the product of the dot product between u and v and the vector v. And then lastly, the dot product between u and the scalar multiple of 3 times the vector v. So let's go ahead and get started with part A. So what we want is the dot product between u and v. And just a side note, if this is our first introduction to doing the dot product, you usually want to make your dot a little bit bigger than you would make a normal multiplication dot, because that indicates that we have a vector multiplication going on rather than just two numbers or scalars. So what is the dot product between u and v? Well, again, considering components in u, we'll call this u1 and u2, and v, say v1 and v2. So the dot product is the component-wise multiplication from one vector to another, and then adding everything in between. So this is equal to u1 times v1 plus u2 times v2. And we would keep going if we had more components. So once we have that, just plugging everything in. So our u1, we have 3 times v1, which is -1, plus u2, 4 times v2, right, which is 5. So you have -3 plus 20. So we get the value 17 as our dot product, which is what we should get, keeping in mind that a dot product between two vectors comes out to be a scalar. So we get the scalar 17. So now part B. Right. So for part B, we're going to take the dot product between u and itself. Well, this is the same thing. We take the first components and multiply them, except the components are going to be the same in this case. So our first component is 3 and times 3, plus the second component is 4, right, times 4. So 3 times 3 is 9, plus 4 times 4 is 16. So the dot product between u and itself comes out to be 25. And now part C. So we're looking for the square of the magnitude of v. Okay. So looking at this, well, the magnitude of v, starting there, we know is the square root of the sum of squares of its components. So it's the square root of -1 squared plus 5 squared. So that's our magnitude, and then we're simply squaring that. So long story short, we see that the square and the square root will cancel each other. So when you square a magnitude, you can really find it just by finding the sum of squares of the components by themselves. So this is equal to just -1 squared plus 5 squared. So 1 plus 25 gives us 26. OK. Now, let's take a look at the last two. So D, we're going to find the dot product between u and v, and then multiplied with v. So before we get to this, pay attention again to our symbols. We have the dot product between two vectors, and then there's no symbol between our parentheses and v, because there's really two different types of multiplication going on. We have the dot product, which comes out to be a scalar. Right. So even if we were starting this fresh, we've already done u dot v in part A, but this is a scalar. So really this is a scalar multiplication, which is why there's no symbol between the parenthesis and v. So OK. So if we were starting fresh, we could go through u dot product v, but we've already done that in part A. So we'll just take that number. So the dot product between u and v, which sometimes we can just say is u dot v for short, right, times the vector v, which our vector v being -1 first component and 5 second component. So scalar multiplication, we just multiply the scalar times each component. So 17 times our vector v gives us the vector with components -17, and 17 times 5 85. So there's our answer for part D. And lastly, okay, for part E, so we have U and dot product, or dotted with, the scalar multiplication of 3 times V. Now again, paying attention to symbols, we have U dot this thing, 3 times V. Well, a scalar times a vector gives us yet another vector. So this is the dot product between two vectors. Okay? Now there's two ways to go about doing this. One way is to note that there's sort of an factoring ability when you're doing dot products with vectors when it comes to scalars. We can factor this scalar 3 all the way to the outside and write this as 3, say, times the dot product of U and V, which would be 3 times, again, the dot product between U and V we found in part A as 17. So 3 times 17 gives us 51. Okay. So that was probably the easier way to do it, since we've already computed the dot product between U and V. The other way to do it is just to do things as they are. So kind of follow the order of operations means I'm going to do everything inside the parentheses first. So I'm going to take U with my dot product of 3 times the vector V, which has components -1 and 5. And so that's equal to U dotted with our vector 3 times our components, -3 and 15. So now we have U dotted with this vector, and again, a dot product is just going to take each component in U, component-wise, multiply it with the components in this vector, and add them together. So the first component in U, which is 3, times our first component here, -3, and then add that with the second component in U, which is 4 times 15. So we get 60 plus -9, and of course, they should come out to be the same. We get 51 as we did over here. So there we go. Thank you very much.